everyone, in this video we're going to go over the worksheet week 9 and we're going to solve the questions. So in the first question we have that this radius of convergency of the power series Cn x to the n is r. So because of that we have that x minus 0 less than r is giving me the interval of convergency. Now when we're trying to find out what happens with the series Cn x to the 4 to the n, so this is essentially like you have x to the 4 power to the n. So this is kind of similar, but what you're going to have is that x to the 4 minus 0 should be less than r because the convergency is being inherited from here. But at the same time, then that means that absolute value of x to the 4 is less than r, and this means that the absolute value of x is less than r to the 1/4. So the radius of convergency of this series now is going to be r to the 1/4. And of course the interval of convergency is just going to be 0 minus r to the 1/4, 0 plus r to the 1/4. Now, the next question is, how is a power series different from the series that we test on the rest of chapter 11, which is the harmonic, the geometric series? And the answer is that there's not really a lot of changes in here. Notice that this formula that we have over here is still assuming that you have similar behavior. So for example, this series from n equals 0 to infinity of this is 1 plus x squared plus x cubed plus x to the n, and continues. And the partial sum of this, if we consider a partial sum here, this is still going to give me 1 minus x to the n plus 1 over 1 minus x. So when we take the limit when big N goes to infinity of this, of the partial sum, well, this is just going to be 1 over 1 minus x as long as the absolute value of x is less than 1, because otherwise this is just going to go to infinity. And so this is very similar in the concept of the geometric series. The only thing that is changing is that you have an x that you don't know what it is, but as long as the absolute value of x is less than 1, then you can still have this relationship. Now, question number 3 says, which test is most useful when finding the interval of convergency for series? And so it says apply it and to find the interval of convergency, radius of convergency for this series. Notice that we have here the series of x minus 3 to the n over 6 to the n times n. And just the fact that we have this n here multiplying is going to make it so I don't use root test. If this n is not here, then I'll use root test because it will be very simple. But just because that n is there, that will give me a very complicated limit of n to the power 1 over n. So I just don't want to overcomplicate my limit. And that's one of the things that I want to do. So here I'll be doing the ratio test, and so I'll be going for limit when n goes to infinity of an plus 1 over an, and on the top is x minus 3 all n plus 1, and below x minus 3 to the n, and this is just going to be limit when n goes to infinity of x absolute value of x minus 3. And here on the top we're going to have 1 over 6 to the n plus 1 times n plus 1, and 1 over 6 power to the n times n as well. We can rearrange this limit, and this is going to be 6 to the n on the top over n, and 6 to the n plus 1 here up the bottom over n plus 1, everything times absolute value of x minus 3. Now I can see this as absolute value of x minus 3, limit when n goes to infinity, and then simplify 6 to the n with 6 to the n plus 1. It's just going to be 1 over 6, so I'm going to put down that 6 here, and I'm just going to be left with n over n plus 1, which is clearly going to want when you apply L'Hopital's rule or when you simplify your limit by factoring out n. So let me just do that here. This is absolute value of x minus 3 over 6, limit when n goes to infinity of 1 over 1 plus n. And this is just absolute value of x minus 3 over 6. Now for this to be convergent, this has to be less than 1 according to the rules for the ratio test and for the root test that are used for convergency. And so this means that the absolute value of x minus 3 should be less than 6. This means that the radius of convergency is going to be 6, and that the interval of convergency is going to be minus 3 minus x minus 3 plus x, or is going to be from minus 9 to 3. Okay. Now, what is left to do here is, of course, verify what happens with these streams. And we want to check what happens when we plug in minus 9 and what happens when we plug in 3. So if we plug in 3, then of course we have the series of 0. And so that converges. And if we have the series of minus 9, then we have the series here of minus 12 to the n over 6 to the n over n. And I can simplify this a bit. I can see this minus 12 as minus 1 to the n times 2 to the n times 6 to the n over 6 to the n over n. That's going to cancel out the 6 to the n. And I'm just going to have the alternating series of minus 1 to the n times 2 to the n over n. But now by criteria of divergency, you can kind of see that this limit when n goes to infinity of 2n over n is going to be different from 0. That actually is going to go to infinity. So this series diverges. And so that implies that the interval of convergency is just going to be minus 9 open to 3 close. Now, exercise 4 requires a little bit more of analysis. We have that the series Cn x minus 7 to the n converges when x is equals 5, but diverges when x equals minus 4. We want to find all the values x where the power series must converge, and all the values x for which this series must diverge, and possibly all the values of x for which there's not enough information to decide. So first and anything, we're going to work with the information that we have. Let's use the quotient rule to establish something. So we get limit when n goes to infinity of Cn plus 1 Cn, and we're gonna have like x minus 7 to the n plus 1 over x minus 7 to the n. This is the regular quotient ratio rule. And so for having that this converges, then we need to have that the limit when n goes to infinity of that ratio times x absolute value of x minus 7 must be less than 1. Okay, and so because we know that it converges when x equals 5, so we know that since x equals 5 converges, we're gonna know that this is part of the numbers that actually fit this type of thing. So if we do that, then we get limit when n goes to infinity of Cn plus 1 over Cn. And let me plug in 5. So if I plug in, I have a 5 minus 7. So it's a minus 2. So I can just say that this limit is less than 1/2. Since I'm going to get 2 over here, and I can just move it to the other side. Now, when x equals minus 4, it diverges. So I have that this limit is going to be bigger than 1. So the limit when n goes to infinity of Cn plus 1 over Cn. And if I plug a minus 4, I'm going to have minus 11. And that should be bigger than 1. So I'm going to have the limit when n goes to infinity of Cn plus 1 over Cn is bigger than 1 over 11. And so that's going to give me some inequalities that I can use in general. So for example, for general convergency, I need to have that the limit when n goes to infinity of an plus or Cn plus 1 over Cn times absolute value of x minus 7, I need that to be less than 1. But on the other hand, I have that this limit here is actually bigger than 1 over 11 absolute value of x minus 7. Just using this inequality, multiply both sides by x minus 7. So this means that for convergency, I'm going to get that x minus 7 is less than 11. And so this means that x minus 7 is between 11 and minus 11. And so this means that x is bigger than minus 4 and less than 18. And so at this point, I have that at least this is a possible interval of convergency. This is what the inequality is giving me. Now, let's check what the divergency gives me. For divergency, I'm going to have that this limit from n goes to infinity of Cn plus 1 over Cn should be bigger than 1. But, so that means x minus 7, sorry, bigger than 1. But in the meantime, this is also less than 1/2 absolute value of x minus 1. I use the inequality to establish this, and so now I have that absolute value of x minus 1 should be bigger than 2. And so that means two things. That means that x minus 1 is bigger than 2, or x minus 1 is less than minus 2. If I have that x minus 1 is bigger than 2, I have that x bigger than 3, or x is less than minus 1. And so I have for divergency this things. Now this is telling me that if x is bigger than 3, it diverges, and I have that if x is if x is less than minus 1, there's going to be convergency. Divergency as well. But this is some contradictory information here, because I have that I should have some convergency here, at least up to 5, but this is telling me that it diverges for something that is bigger than 3. So because it's bigger than 3, but also I know that converges when x is equals 5, I know that it at least has to be from 5 onwards. And so what I can do is I kind of can cut the convergency, and x less than equal than 5. Since bigger than 5 will be bigger than 3, and this is telling me that this is likely going to be divergent in there. Also, I also have that x less than minus 1 is potentially something divergent, but I here have that this converges up to the point where it's 4. So for something that is less than minus 4, then it's probably when we're going to have the divergency. Not only less than 1, but less than minus 4. So because minus 4 doesn't converges, then we have that the interval of convergency gotta be this one. So as you can see, this is a little bit of convoluted information, and there are points where you probably don't have enough information to decide really. So you go between 5 and 18. This is telling you, hey, this could be converging here, but you're getting contradictory information here, where it says it could be divergent. So there's not enough information to decide in there. So just for numbers between between -1 and 4, so we know that it diverges when it's -4, but that doesn't mean necessarily that this has to be the lower bound. So what I should do is I should change this to -1, since that's the minimum possible that I can have here, and I can have -4 after this. So since I'm just saying between -1 and 5, this is going to be convergent, and then I don't know after between -1 and -4, it might converge, it might not converge, but I don't know yet. I don't have that information. So that's the type of analysis that you can make in here. Now for question 5, do you want to find the radius of convergency of the series from n equals 1 to infinity of 3x minus 2 power to the n over n squared, and you want to know what is the center of the power series. So to find the center of the power series, you should be able to factor this 3 out, and so you can rewrite this here instead as 3 to the n, and this is x minus 2/3 to the n over n squared. And so now you know that the center is really the point 2/3, and the coefficient is this 3n's over n squared. Now let's check radius of convergency for this. So because we have n squared below, I don't want to go for root test, so I'm going to go with ratio test. So I'm going to go limit when n goes to infinity of an plus 1 over an, and this is just going to be absolute value of x minus 2/3, since n plus 1 is going to cancel with n. And now going back to what really is the sequence is 3n over n squared, so this is going to be 3n plus 1 over n plus 1 squared over 3 to the n over n squared. And now we can simplify a bit so we can calculate the limit. So we're going to have 3, and here we're going to have at the top, we're going to have n over n plus 1 squared, x minus 2/3, an absolute value. And you already know the trick that we use for this type of limits, and this is going to be 3 times absolute value of x minus 2/3, limit when n goes to infinity of 1 over 1 plus 1 over n square. And so this is going to 1. And so at the end, the limit is just going to be 3x minus 2/3. And in order to be able to be convergent, this has to be less than 1. So now the radius of convergency is going to be, of course, 1/3. We divide by 3 on the other side. And now the interval of convergency here is going to be the point -1, and this is 1. Since we pretty much break apart this is like x minus 2/3 between -1/3 and between 1/3. So if we're adding both of those directions, wait a minute. So we add here, we get 1, but if we add in this direction, we actually gonna get 1/3. Sorry, so it's not -1, but 1/3. So this is what the interval of convergency is. And so that's the end of worksheet 9.